Welcome to today's lesson on relations and functions. Before we get started, make sure that you print out your note guide so that you can take notes as we go along, or take out a piece of paper and make sure that you have something to write with. This lesson on relations and functions is lesson 2 in Unit 3. It is going to take us a couple of days to get through this lesson, so we're going to do part 1 of this lesson today, and then we will continue with part 2 of this lesson tomorrow. The vocabulary that we will be going through as part of this lesson is as follows: set, element, finite, infinite, relation, domain, range, function, and the vertical line test. I know I've told you a number of times, but I think that one of the reasons math is confusing for students is they don't understand the vocabulary. So we're going to go through this set of vocabulary, and I want to make sure that you understand what all of these words mean. So let's start with the first 4 words on our list: set, element, finite, and infinite. A set is a collection of objects. An element is one item in a set. If there is a limited number of elements, we call this finite. So you need to be able to list all of the elements. And if there is an unlimited number of elements, we call this infinite. So at this point, if you're not done copying these down, you can go ahead and push pause on your video, continue to copy these down, and then push play. On the screen here, you can see that we have a picture of a drum set. This is an example of a set. You can see that we have different parts of this set. I'm not a drummer, so I don't know what each of these different parts are, but we have a big drum here. We have one that's smaller. We have another drum here that's smaller. I know these are cymbals for sure. So each of these parts would be considered an element in this set. Okay, so this is a drum set, and then each of the parts of this set would be called an element. We know that this set is finite because we can actually list and count the number of elements. This image is an image of a stack of books. We can also call this stack of books a set of books. Each of the books in this set would be called an element, and this set is finite because we can list the elements and we can count how many elements there are. Here we have an image of a set of dishes. Each of the dishes in this set would be considered an element, and this would be a finite set because we can list the elements. This image is an image of integers. Notice that we have a number line here, and our positive integers go on forever and ever and ever in this direction. We have negative integers going on forever and ever and ever in this direction. This set of integers would be considered infinite because the possibilities of integers is limitless. Okay? Each of the numbers or integers in this set would be considered elements. So this is an example of an infinite set. The next 3 words that we're going to talk about are relation, domain, and range. A relation is a relationship between sets of values. In math, the relation is between the x values and the y values of ordered pairs. The set of all x values is called the domain, and the set of all y values is called the range. So go ahead and pause the video as you copy down this definition for relation, and then push play when you're ready to move forward. In math, there are a few common ways for representing relations. Up here on the screen, you can see a few of those. You can see this relation has been represented as a set of ordered pairs. This relation has been represented as an arrow diagram. This relation has been represented using a table, and this relation has been represented using a graph. Okay, so let's go ahead and look at these one at a time, and we are going to talk about the domain and the range of each of these sets. So here we have a set of ordered pairs. As we go through this set, we have the ordered pair -9, 1, the ordered pair -5, 5, the ordered pair 1, 8, the ordered pair 7, 1, and the ordered pair 7, 4. And we learned in the lesson on the coordinate plane that ordered pairs are always listed x first and then the y. So if we want to list the domain and range of this set, we need to go ahead and identify the x values and the y values for each of these. So -9, 1. The x value is -9, the y value is 1. -5, 5. The x value is -5, the y value is 5. 1, 8. The x value is 1, the y value is 8. We've got 7, 1, and we've got 7, 4. Okay, so in our range, if we list, in our domain, if we list the set of our domain, okay, the x values, those are elements of this set. So let's go ahead and list the domain. We have -9, -5, 1, and 7. We don't need to list 7 twice. Okay. And then let's go ahead and list the set of our range. Or list our range as a set. Okay, so our range is 1, 5, 8, 1 again, and 4. So in this set of ordered pairs, which is finite, we have different elements within the set. The domain of this set is -9, -5, 1, 7, and 7. Remember, domain is your x values, and the range of the set is 1, 5, 8, and 4. Okay, remember the range is your y values. An arrow diagram is another way to represent a relation. And in this arrow diagram, these are our x values and these are our y values. So if we want to list the domain of this representation and the range of this representation, we can do that. The ordered pair here would be -9, 1. And that ordered pair has just been put in an arrow diagram. Another ordered pair we have here is -5, 5. We also have 1, 8, and then we also have a 7, 1. And we have a 7, 4. Sorry, I ran out of space here. Okay? Now these are our x values and these are our y values. So the domain of this relation would be -9, -5, 1, and 7. The range of this relation is 1, 5, 8, and 4. Okay, let's go ahead and look at another one. Okay, here we have a relation represented by a table. If we want to list the domain and range of this relation, we can see that our domain, or our x values, is -9, -5, 1, and 7. And our range, or our y values, are 1, 5, 8. We already listed 1 and 4. Okay. So this is the domain and range of this relation that has been listed in a table. For this next one, in order to list the domain and range of this relation, we are going to need to identify what the ordered pairs are for the relation. So we have one right here. If we want to identify what ordered pair that is, we're going to start at the origin. To get to this point, we have to move to the left 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 1. This ordered pair is in quadrant 2, so we move to the left 9 and up 1. For this ordered pair from the origin, for this point, to get to the ordered pair from the origin, we count to the left 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5. So the ordered pair for that point is -5, 5. The ordered pair for this point, which is in quadrant 1, would be to the right 1 and up 1, 2, 3, 4, 5, 6, 7, 8. And then we have 2 more here, both in quadrant 1. To get to this point, we have to move to the right 1, 2, 3, 4, 5, 6, 7, and up 1. So +7, +1. And for this point right here, it would be +7 and +4. Okay, so now that we have our ordered pairs listed, if we want to find the set of the domain and the range, we would have -9, -5, 1, and 7, and we would have 1, 5, 8, and 4. Okay, so those are some different ways of representing relations, and then I just showed you how to find the domain and range of each of those relations. So here are a few more examples. This says state the domain and range for each relation. We know our domain for this relation would be 100, 120, 140, 160, and 180. And the range would be 5, 6, and 12. Okay? If we go ahead and look at this arrow diagram, we can see that our domain is -3, -2, -1, 0, and 1. And our range is -6, -1, 0, 3, and 15. I want you to notice here that this 1 is being mapped to 0 and it's being mapped to 15. So that would be two different ordered pairs there. That would be 1, 0 and 1, 15. Okay, so that 1 is being paired, that x value of 1 is being paired with two different y values. Okay, let's go ahead and look at number 3. If we were to identify the range of this relation, we can see that we have an x value of -4, -2, 2, and 3. Okay, and then our range would be -2, 1, 2, and 4. Okay, whenever you have a representation of a graph for a relation, it really is easiest if you list the ordered pairs. Okay, and for this one, you can see that 3 is being paired with both 1 and 4. And that brings us to our next set of vocabulary words. So we have function, vertical line test, and function notation. We're going to end this lesson after we talk about function and vertical line test, and we will continue with this lesson tomorrow with function notation. So a function is a special relationship where each input has a single output. Every function is a relation, but not every relation is a function. So go ahead and pause the video and make sure that you have this information written down. And then push play when you're ready to move forward. Okay, here are 3 different examples. We actually used these examples when we were talking about domain and range of each relation, but I want you to now look at them to determine whether each of these relations is a function. So let's look at 1. In order for a relation to be a function, each x value has to be paired with a different y value. Okay, so we can see that we have 100 and it's being paired with 5. We have 120 and it's being paired with 5. We have 140, it's being paired with 6. We have 160 being paired with 6, and we have 180 being paired with 12. So as we look through this relation, there are no elements of our domain that are the same. They're all different. So we have no x values that are being paired with more than one y value. I think the easiest way to see this, to see whether this is a function or not, is to do it as an arrow diagram. So we have 5, we have 5, we have 6, we have 6, and we have 12. So we know the 100 goes with 5, 120 goes with 5, 140 goes with 6, 160 goes with 6, and 180 goes with 12. So each of the elements of our domain are here, and we have the elements of our range here. And each of our x values are being paired with a different y value. Okay, so this would be considered a function. Let's go ahead and look at number 2 though. As we look through number 2, we have -3 being paired with -6, -2 with -1, -1 with 0, 0 with 3, and then this 1, it's being paired with both 0 and it's being paired with 15. So we would say that number 2 is not a function. Because we have 1 that's being paired with both 0 and 15. Okay, and that can't happen with a function. For it to be a function, remember that each input has to have a single output. And so these are our input. These are our output. And this input right here has more than one output. Okay, let's go ahead and look at the next example. Okay, so for this example, we have a graph. Let's go ahead and list the ordered pairs in this graph. And we already did this on the other example. So -4, 1. We have -2, 2. We have 2, -2. We have 3, 1. And we also have 3, 4. Okay, and if we go ahead and list this as an arrow diagram, our inputs would be -4, -2, 2, and 3. Okay, that would be our domain. And then our outputs would be 1, 2, -2, and 4. Okay, so if we go ahead and pair these, the inputs with the outputs, -4 goes with 1, -2 goes with 2, 2 goes with -2, and then 3 goes with 1, and 3 goes with 4. Okay, so we would say that this is not a function, because remember, in order to be a function, there has to be each element of the domain has to be paired with only one element of the range. Okay, there is another way that we can identify whether a relation is a function or not, and it is called the vertical line test. Okay, and how this vertical line test works is if you can pass a vertical line through the graph and it touches only one point at a time, you could say that that relation is a function. So if we look at number 1, you can see when we pass this vertical line through here, and we can pass it anywhere along this graph, and it's never going to touch more than one point at a time. And so we would say that this is a function. Number 2, you can see that if we pass a vertical line through here at any point in the graph, it's only going to ever touch one point at a time. So we would say this is a function. If we look at number 3, this one's a little bit tricky, but there actually is the graph of a blue line underneath the graph of this vertical line. And so we can see that this vertical line is touching every single one of these points at the same time. So it's not a function. Number 4, we would say, is a function. There's not any place along this graph that we could pass a vertical line and pass through more than one point. Number 5 is not a function. Okay, so we have this graph of a circle, and we can see that when we pass a vertical line through this graph, it's touching both this point and this point at the same time. And the ordered pair for that point is 1, 3. And the ordered pair for this point is 1, -3. So if we were to list all of the points on this graph, then we would have the x value of -1 being paired with more than one y value. See how -1 is with 3, and -1 is also with -3. And then the last one, this one is a function. There's not any place that we could pass a vertical line and have it touch more than one point at a time. Okay, you guys, so it is quiz time. I know this lesson was full of lots of new vocabulary. If you would like to do your quiz on the board in class, that would be really great. That way you can make sure that you've done this correctly and that you understand everything that you need to before you turn it in. So the first question says, list the set of ordered pairs included in this relation. Okay, so you've been given a relation here. This is your domain. This is your range. Okay, so for question number 1, you're going to list this as a set of ordered pairs. For question 2, you're listing the domain and range. And for question number 3, is this relation a function? And how do you know? Okay, the how do you know part, that is an important part of your quiz. Okay, so is this relation a function? You're going to say yes or no, and how do you know? Okay, you guys, I hope you have a really great day, and I will see you soon.